Hello, welcome to the last video on dividing rational expressions. This example is going to focus purely on taking the quotient of expressions with rational exponents. So again, if you need help with the rational exponents and kind of the properties that govern what is legal and what is not legal, please look at that little half sheet of paper that I gave you. I'll also upload one into Google Classroom with this video as well. So the first thing that I will do is I will rewrite this as a multiplication problem. So we have negative 3x to the negative fifth, y to the negative third, divided by negative 2x squared, y to the negative fourth power, and we'll multiply by the reciprocal 9x, y to the negative second, times 4x to the negative 6 times y. So what I told you in class to take care of first was to reduce the coefficients. So here in this example, I don't want to draw my equal signs. Here I have a let's see, do I have anything that cancels right away? And here, I don't believe I do. I do have negatives, so we'll just go ahead and I'll multiply. Okay, 3 times 9 is 27, and it is negative. Negative 2 times 4 is negative 8. And two negatives cancel out, and we get a positive. So we have 27 over 8. And now I'm just going to group my variables. Here I have x to the negative fifth times x to the first, y to the negative third times y to the negative second. Okay, and those just came from up here. I just put them together. Next, I'll do the same thing with the denominator. Here we have x squared times x to the negative sixth times y to the negative fourth times y to the first. And now what I will do is I will utilize the product property. Okay, and what I'm going to do, I'm just going to add these values, right? Same variable is multiplying, so we add their powers. And what we get is 27 x to the negative fourth y to the negative fifth over 8x to the negative fourth y to the, oh, my pen's messing up. I think it's negative third power. Yeah. Okay, so I've combined all my x's top and bottom, and now what I will do is I will make sure all of these are positive. So this is the negative exponent property. And I'll just go ahead, if it's negative, I'll move it to either the numerator or the denominator. I'll move it away from where it was, and you can see all these variables are going to be switching values. So this x to the fourth is going to move into the denominator, and now it's positive. This y to the negative fifth is going to move into the denominator, and now it's positive. This x to the fourth is going to move into the numerator, and now it's positive. Y to the third into the numerator, and now it's positive. And you can see now all my exponents are positive. The last thing that we have to do in this example is go ahead and use our quotient property. If you happen to have, like, say this was x to the fourth, positive 4, and I moved this 4 down, then you would have to use the product property again to combine them. But here, notice I don't have any like I guess, like terms. I don't have any variables, right, with the same base in either the numerator or the denominator. So what I can do is I can go ahead and use the quotient property. What that says is if you are dividing a variable with the same base, you subtract their powers. So I have 27 over 8, and you should notice that these match. These end up canceling out. This is essentially x to the power of 4 minus 4, which is 0, and then this is an identity. Anything to the 0th power is just 1. So it cancels out. Here I have y to the 3rd over y to the 5th, and what I'm going to do is I'm going to move this down into the denominator, and you'll see why I'm doing this. This is y to the 5th minus 3. Okay, and you can imagine, like, if I just reverse the negative exponent property, here it is y to the power 5 times y to the negative 3rd. I combine these, and we get our answer 27 over 8 times y to the 2nd. So this is your answer, and if you're still a little bit shaky about what just happened here, you can go ahead and you can use this idea. This would be 27 over 8 times, this would be y to the 3rd power minus 5, and this just gives you 27, sorry, I'll just go down here. This would give you 27 y to the negative 2nd power, and again, we want positive exponents, so we move it into the denominator. Okay, so different routes you can take, but this is our reduced expression, our quotient. Okay, that is it for this lesson on dividing rational expressions. If you have any questions, please shoot me an email. Please try the practice problems that will also be posted. Give them a go before you take a peek at the answer. All right.